When it comes to machine learning, there are a few common strategies: regression, classification, and clustering. So let's talk about classification models. First, it's important to note that classification models are supervised machine learning techniques. The goal of a classification model is to predict the class of the items in the given input dataset. So, for example, you can classify what sort of fruit is in a picture, or you can classify whether a patient is diabetic or not. And since this is supervised machine learning, it means that we train classification models with features and known labels. So, for example, we'd train a classification model to predict whether patients are diabetic by feeding in tons of data that shows the model characteristics of patients that we already know are or aren't diabetic. Now, once a model is trained, then we can use a trained classification model to predict labels for datasets that don't have the answers in them. Now, there are lots of different kinds of algorithms available to you when you're implementing a classification model. Some common algorithms are artificial neural networks, naive Bayes, decision tree, random forest, k-nearest neighbor, stochastic gradient descent, logistic regression, and support vector machines. Let's dig into these a little bit. First, let's look at an artificial neural network, or ANN. ANNs, usually just called neural networks, are effectively a collection of connected units, or neurons, that each take inputs and produce an output. Now, each neuron receives signals, like numbers, and then computes some nonlinear function to produce an output. Now, each neuron carries a certain weight, which can be adjusted based on learnings. Regardless, each of the neurons are then arranged in a sort of network composed of various layers. Now, as signals are fed into the neural network, they flow through the appropriate neurons at each layer, ultimately produce an output. In reality, a neural network is generally a composition of multiple other types of algorithms. Next, we have decision trees. A decision tree algorithm is pretty easy to wrap your head around. Each data point in an input dataset is analyzed individually, and depending on the characteristics of that data point, reach a conclusion at the bottom of the tree. So take this image for example. Our data point carries information about somebody's day. The decision tree helps us predict whether the person should get up or stay in bed. The tree itself was built by evaluating what other people generally did in these conditions. So if our fictional person's day suggests that it's a weekday,